is an assistant professor in computer science and engineering at the University of Michigan, also affiliated with the School of Information. He holds a PhD in human-computer interaction from Carnegie Mellon University, a master's in HCI from Georgia Tech, and a bachelor's in electronic information engineering from BUPT. He has also worked in the Ability and Intelligent User Experiences group in Microsoft Research, the HCI group of Snap Research, the Accessibility Engineering team at Google, and the Mobile Innovation Center of SAP America. And we also have Jalen Herskovich, a PhD student, and we are very excited to welcome them to talk about their work with the team at the University of Michigan Human AI Lab, who have been working to develop new assistive technologies for blind and visually impaired people. Thank you, and welcome, Anhong.
Thank you so much for the introduction, and thank you for being here and inviting us to this event. So my name is Anhong. I'm a faculty in the University of Michigan, and
I'm Jalen Herskovich. I'm a PhD student at the University of Michigan.
Cool. And we are both part of the Michigan Human AI Lab, and today we will talk to you about our work on building AI-powered assistive technologies. So who we are, so this is roughly our lab. We have about 5 PhD students and 5 to 10 master's and undergraduate students. So today, I'm here, Jalen is here, Lei, who is another PhD student, and Ellie, who is a summer intern, who are with us, and they are upstairs, and you might have talked to them earlier today. And feel free to check out our booth at the 21, is that 21? Yeah, later. So what do we do? So in our research, we design, develop, study, and deploy human AI intelligent interactive systems to enhance the accessibility of the real world and the digital world. And in our research process, we really highlight the unique needs of people with disabilities so that technologies can best support these needs. And as you can see, we have like 3 main pillars of our research: accessibility, artificial intelligence, and augmented and virtual reality. So what is our research process? So we do HCI research, human-computer interaction. And we generally follow this iterative loop, which is, start from understanding people and challenges. We iteratively design solutions with and for people. And we iteratively evaluate our solutions with people. And then we work towards public deployment to really reach, put out what we have built into the hands of end users. So one thing you can see in this cycle, and we keep iterating within this cycle, is that there are people at every stage of this process. And, and we have been, the projects that we do is about people, and we engage people in many different ways. So how do we do that? And we have conducted in-person and remote studies with people with disabilities to learn and evaluate our work. And we conduct interviews, survey studies, co-design sessions, prototyping, and testing the prototypes that we develop, and also inviting people to publicly try out the apps that we have developed. And we have been recruiting participants through prior contacts, through many local organizations, and hopefully from you in the future. So our research have involved thousands of people with disabilities as students, researchers, practitioners, participants, and users over the years. And what are some impacts that we make and we want to make in our previous work and in the future? So throughout our research, we gather insights, design ideas, and we build prototypes, and we deploy full applications. And we have deep connections with organizations such as the Library, Disability Network, NFB, and the local chapter, Access Computing that promotes accessibility in computing education, the Lions Clubs, the Greater Detroit Agency for BVI, and the University of Michigan, CFDC, and many other local organizations that we are able to connect and talk to today at the event. And also over the years, we have been building connections and working with many companies who have been developing assistive technologies, such as Apple and Google. I've personally interned at the Google Lookout team and developing some features for that. And Jalen have interned at Apple twice in their research team developing assistive technologies. And Microsoft and IRA and Meta, so I have a student who is doing an internship at Meta this summer. So, so for today, we want to share kind of the different areas of research that we have been doing and what we have produced. So we are going to talk about our research on making physical appliances accessible, making digital media, a physical world, and also some more futuristic like immersive media, mixed reality accessible. So first, we're going to talk about making physical appliances accessible. So the first project I want to talk about is VizLens. And throughout, when I was a PhD student, I've been developing this line of work on how do we use computer vision and maybe crowdsourcing, a combination of human and machine intelligence to make this kind of inaccessible flat panels accessible for people who are blind and low vision. So we have developed some apps that allow users to take a picture of this interface and is able to analyze the buttons and the elements on this interface and then allow people to use it in real time. And we have several extensions. And what I want to highlight here is that in the past couple of years, we have been developing and this application further, and this is currently available for free on the App Store, and so feel free to check it out. We also have demos if you want to try out at our booth later. So feel free to go to VizLens.org to try out this application. And I want to now show you a video that I worked with the Michigan Engineering Press Release Office just to showcase how this application works, to give you an idea of this project. So the first one is called VizLens. It's an app to help blind people access inaccessible flat touch control panels, such as this microwave. So I'm going to show you how this works a little bit. I can create an interface, and it will ask me to aim at the camera at the interface and take a picture, so I can continue, and I'll be able to aim at this interface and take a quick picture. So this will be processed. So as you can see, like the various buttons and text are analyzed, and I can choose to edit this interface a little bit. So for example, for this button, I want to split this, and all right, it looks good, so I can confirm. So I can add a name saying this is lab microwave and save this. Then when the blind user want to use this interface, they can open this, and there are two different modes. One is called virtual interaction mode. So basically the blind user is able to navigate through the interface on their screen using a similar settings as VoiceOver. So
Undo, Hamilton Beach, baked potato, popcorn, pizza, beverage.
So as you can see, they can
Frozen dinner. Repeat.
Navigate around
Power
and
level.
listen to what are the buttons. They can also move their finger around and listen to what the buttons are. Another mode that is sort of the more novel part of this application is this live interaction mode. So the user can navigate to this live interaction mode at the bottom, and then the user can aim at the interface, and as you can see, when the interface is in or out of the view, there is a background sound to indicate that. So once the microwave control panel is within the field of view, the user can move their finger up.
Defrost. Wait. Time defrost. 3, 6, 9, 8, 7, 4, 2, 9. Add 30 seconds. Start pause. Add 30 seconds.
So for example, the user found the add 30 seconds button.
Add 30 seconds.
They can click it to
Add 30
activate,
seconds.
and then when they want to start and pause this,
Stop clear.
they can click
Stop
the button
clear.
to stop it. Yeah, so that's a clip to show you how this app works. And so this is one of the examples that we have started from research, and then we make it robust, and we address many other challenges along the way from users iteratively over the years, and then we put it out there and engage people and try it and give us feedback. So we have deployed this since last summer, and we have got a lot of great feedback that we're hopefully going to incorporate in the near future and to make the app better. So along the same lines, and we have also been developing kind of more research prototypes for the future. So for example, a follow-up project that was just published last year is this kind of also aim at addressing interface accessibility, for example, for kiosks and public touchscreens. And what we did is we developed a phone case that the user can mount their smartphone into, and the user can focus on brushing on this interface without really knowing where the interface is, and don't have to have the very precise movement on the interface to locate each individual element. But this phone case is in charge of that and be able to click the right buttons at the right time for the user. And we use these touchscreen actuator and this perception using computer vision and also an interface model. And the user can use whatever assistive technology they want to use already, such as voiceover, assistive touch, Braille display, to command this system. And then this hardware will act as a proxy to perform the interaction for the user. So let me play a short clip about this prototype as well.
BrushLens is a hardware device that is wirelessly connected to the user's smartphone. It can be attached to the smartphone as a phone case and uses an array of solenoids covered with conductive fabric to actuate the screen. When activated, each solenoid can punch the screen, thereby simulating the touching gesture. Using the smartphone camera and the IMU data, BrushLens can perceive the interface and precisely determine when to touch, allowing users to brush on the screen and delegate the precise actuation to the system.
Yeah, so in that clip, what you just saw is that the user was able to specify, like for example, a sequence of interaction they want to perform, and then move this phone case following an audio guidance, and then the phone case will click the buttons for the user at the right time, so which addresses many of the kind of the last inch actuation problem. Yeah, so, and also one thing I want to mention is if you have any quick questions during the talk, feel free to raise your hand. So we're meant to make this a very interactive session. So that's kind of a couple projects.
Okay, well, I just want to mention, you can raise your hand and then I will bring this microphone to your face, okay? So any questions right now?
Yeah.
Okay, wait, one sec. I'm coming around. Here we go.
I have a question about how do you get involved in either beta testing or whatever other activation we can be a part of?
Yeah, that's a great question. So at the end of this talk, and also feel free to check us out at the booth, we have set up a page specific for today's event with a Google form that you can put in some basic information of what kind of studies are interested in, and then we will reach out to you when we have studies coming out. So for example, in this past several months, we have run 3 different studies, and some projects we'll talk about. One is Jalen will talk about the work on allowing blind and vision impaired people to create personal assistive technology through different kinds of programming methods. And the other is providing real world live descriptions. And the other is enabling blind people to edit photos. So we run those studies from late March to mid-April. And we are also planning to run a series of studies in the summer and going forward. So yeah, please, we will share more information, but we'd love to work with you. 20 or 21, I forgot, but it's.
I think it was 21.
Yeah, it's in between Kellogg and the AD guys.
Okay.
Yeah.
Let me grab another question. There's a couple. Okay, pardon.
Can we pick up literature on all the things you're talking about at booth 20 and 21, or whichever one it is?
Yes. So we have set up a page that's humanailab.com/visions.html. So if you go to that page, all of the information are there with project information, some quick links to these apps, these research videos, and also a page to the labs, which is my main website that has all of the details of the projects, like paper links that are PDF accessible, and videos, talks, etc. Yeah.
Cool.
And you have the information that you just gave to me available at the table telling us what the website name is, et cetera?
Yes.
Okay, great.
So this is the page that we set up, which is HumanaLab at Visions 2024. If you go there, you will see a bunch of information of how to get involved and some of the videos and a few projects. And yeah, you can find more about us there.
Okay.
Okay.
We got a question here.
Can you please phonetically spell what you're saying, because I don't understand all of the words.
Yeah.
So the website, can you phonetically spell that out?
Yeah. So the website is humanailab.com/visions.html.
Okay, great, thank
Yeah. And at our booth, we also have Braille handouts and QR codes that you can scan, quickly save those information.
Thank you.
All right. So that was the first part, and next we will shift from physical appliances to digital media. And I think Jalen will talk about a couple of projects there first.
Hey, great. Hi, can everyone hear me okay? Okay. Yes. Great, thank you. Okay, so in the digital media space, we have a couple of different projects. So one of these is techniques for blind and visually impaired users to explore image contents through touch exploration. So by running your finger over a phone screen, the phone will read out information that's beneath your finger. And our goal here is kind of to convey the layout of images, aside from just the text and the caption, and allow people to interact with the image more deeply. This app is also something that we've deployed on the iOS App Store, which has over 500 uploaded images at this point, but it is available as well at ImageExplorer, all one word, all lowercase. That's imageexplorer.org. And we have a short video for this app as well.
Another app we have developed is called ImageExplorer, which aims to increase understanding of image contents for people who are blind and low vision. So the way it works is the user can open the ImageExplorer app, and they can select image from a variety of sources, such as they can take a photo, they can select from their photo album, they can pick an example image to learn more about how the app works, or if they are on the website or on the social media, they can share that image to our app to get analyzed and use the features here to learn more about the image. So let me show you an example image.
A couple of women walk down a sidewalk.
Okay, so I will select this image.
Image page.
So in this first page, it will show a list of textual information about this image, such as the caption,
Caption. A couple of women walk down a sidewalk.
kind of
Tags.
different tags,
Plan, leisure, shoe, luggage and bags, footwear, leg, gesture, bag.
as well as kind of information based on count and position.
Count information. Person, 5. Bench, 2. Handbag, 1. Positional information. In the middle center, 1 person. In the middle left, 1. In the middle right, 3 person.
All right. So after the user navigates through this information using this textual format, the user can also enter a touch exploration mode. For example, the user can double tap on this image.
Landscape.
So then the user is able to move their finger on the image to learn more. So for example, once I start touching, it will play a background sound indicating that I'm on this image.
Person 1. Double tap.
So
to
once
explore.
my finger enter a specific object, in this case a person, it will have a short vibration as well as tell me there is more details that I can double tap to explore. So for example,
Showing
now I
some
double tap.
objects of person 1. A woman is wearing a white shirt. Handbag. The skirt is white.
Right, so I can move around and kind of get more access and details about the sub-objects of this person. So I can double tap the exit, and then I can basically continue to learn more about the other parts of the image.
Okay, so that was ImageExplorer, which is an app for exploring image contents through text and through touch. Slightly different topic, also in the space of digital accessibility. Another project that we've worked on is Collab Ally, where we looked at how to make the collaboration queues in Google Docs, which is an online document editing website, accessible non-visually. So Google Docs has a ton of visual cues to indicate what your collaborators are doing in the document. So things like different colored cursors, highlights, floating comments, all of these things indicate how people are editing a document. And these are all things that a sighted person can view as they work and have this awareness of what their collaborators are doing at any given time. So in this project, we worked to make those visual cues accessible non-visually. And we did this in collaboration with Ju Young So, who is a researcher from the University of Illinois who's blind. to develop these non-visual alternatives. So I'm going to play a short clip showing how there's audio feedback that comes from the extension we developed based on the collaborator's location in the documents and how he reacts when he hears that they leave a comment.
Oh, this ear con indicates somebody has just came to the same paragraph as mine. I wonder who that is. And oh, somebody has just left a comment. Let me check it out by pressing Alt-Shift-1. Let me press comments button. Here is comment summary on page 1. Oh, so she left this comment. So let me use blind people as a reply.
Okay, so that was Collab Ally, again, a project on making Google Docs, which currently not all the features are accessible, so we worked on digital accessibility in that space as well.
And a more recent project, so we have been looking more into some applications that can be powered by the new advances in generative AI. And one thing we're working towards is creation tools for blind and vision impaired people. So in this project we call Edit Scribe, we are trying to make image editing non-visually accessible. So this show a web prototype of a web application that show you like the initial image and the before and after, so the user is able to input a natural language command, such as in this case, making the color of the cat from red to blue. And then we use computer vision and large language models, large multimodal models to be able to perform those manipulations and then inspect what happened. So this show you a more detailed breakdown. So we kind of provide different kinds of feedback, such as, a summary of what changes have been made. And the AI taking all of the information into consideration, the image before, the image after, the user's command, and also all the captions that was generated to give you a summary of what you think, whether it's successful or not, so to help the user make a more informed judgment of what's going on, as well as like the new fresh description for the image. So for example, if you say remove this person, if the new description doesn't see a person, you are probably more confident that the person is not there, and it doesn't see like even a contour, which can be an artifact when you remove objects, right? So in this project, which is still very preliminary, we are trying to make image editing accessible using large language models and natural language verification loops powered by these large models. And we are hoping to make this more robust to support people upload their own images and then deploy this publicly on the web for people to try it out. So we recently run some studies on this, but there are a lot of future potential that we want to do. Yeah.
Okay, so jumping back to the physical. So we've talked about physical appliances like microwaves, interfaces like that. We talked about digital media. Jumping back to things in the physical world, we're kind of interested in these camera-based assistive technologies where you can point your phone camera out at the world and get some information. So in practice, these assistive technologies, things like Seeing AI or other camera-based mobile apps, are kind of one size fits all. So they offer things like currency recognition or text recognition, but they can sometimes fall short of supporting people's unique needs and preferences. So this project was born out of interviews with 12 blind participants who worked with us on this research to understand the gaps in these applications and understand the situations where they would want to customize these applications or create new solutions. So I want to kind of walk through an example of this given by one of our participants where they wanted to use the artificial intelligence application Seeing AI to sort their mail. However, when they use their phone's camera to scan the envelope, instead of just reading out the information that's relevant to them, which in this case is their name, the app frustrated them by reading all of the text that it could see repetitively. And so in response, this specific participant imagined being able to filter text based on relevant things to them, ignoring everything else and hopefully reducing their mental load of doing these tasks with AI. And then based on the people that we spoke to, my guess is that maybe many of you have also faced similar situations with these AI apps. But this is just one example of how people might want to search for specific pieces of information out in the real world. So based on examples from our interviews, we designed and built a prototype application, which we're calling Program Ally, where people can program exactly what information they're looking for out in the real world. So for example, someone may ask, find date on groceries, if they're just looking for, let's say, an expiration date. And then when they run this filter, the app only reads out that information. So I'm going to play a video.
Expiration date program, button. Runs the program. Pause running, button. No date found on grocery product. Found date, January 10th, 2024, brown. Found date, January 10th, 2024, yellow-orange.
So comparing this to other popular assistive applications, for example, Seeing AI, where Seeing AI short text mode reads all of the text in frame, but it might be difficult to target certain pieces of information.
It in facts, usenames per container, 112 cut 100, mon facts, is per container, I facts, ags per container, 120309, comma, 100% daily value star, 0%, 0%, 0%, 5%.
So in the video there of Seeing AI, I heard some laughter. In the video there of Seeing AI, the date was in view of the camera, but it didn't read it because it was busy reading out all of the other text that was also there. And then I won't play a video, but Be My AI, which is powered by GPT-4, it's a newer assistive application out there, requires users to take a picture containing the information that they want, which can be difficult. And even then, once a photo is taken, sometimes the specific information is still buried in this longer description. So yeah, our hope is that with apps like Program Ally, give me 1 second, sorry. My hope is that with apps like this, we can help people personalize their assistive technologies to better meet their daily needs. And again, this is an app that we want to continue to develop. I'm sorry, I saw a hand raised over there.
I was wondering how you programmed it to read the expiration date.
Yes.
Like, is that tricky?
So we tried to create a couple of different ways for people to do this to reduce the difficulty. So one way is going into the settings of the app, and you can use a drop-down menu to pick what you want to hear. Another way that we added is you can ask the app a question, and it will turn that into a filter that you can then run and reuse if you want. So yeah, great question. Thank you. I see another hand. Oh, sorry. One back there first, and then we'll go to the front after.
Okay.
Can you ask the app to talk slower because they talk very fast?
Yes, so yes, that is, I think, maybe a commonality through a lot of these videos is, as you can hear, VoiceOver sometimes talks quicker, sometimes it talks slower. That's a setting with the device itself, not the app, so that's something someone can personalize. I think you can pick a voice, a speed, all that good stuff. But yeah, that's outside of the apps that we develop, but yes. Okay.
I've got the microphone if you want to have some.
Oh, okay. So I use Being, I use what's the thing with the seeing, not Seeing AI. What is that? The new Chat GPT. Be My AI. Yeah, and you can take a picture. So this is basically the same thing I'm imagining, but you tell it what it wants to, you want to find, and then it'll scan the image and it'll pick out from that image the text that we're looking for. Like I could do the same thing with Be My AI, but I'd have to type into it. I'd have to spend a lot more time. But this kind of works the same way in rendering the images, correct?
Yes, similar. So like you said, Be My AI, you need to type a question into it. The other difference with Program Ally with this app is that it doesn't need an image that you have to aim the camera and take a single photo. It just opens up the camera and the camera is running continuously. So as you were to move the camera around, or let's say you need to rotate the object to find the date on the other side, it can read out updated information as you move. So, yes.
Cool.
Thank you.
Okay, we got, I see it. Let me run to the back. Here.
Yeah. Will it also read denominations of money too?
So Program Ally, this specific one is not for currency recognition. I do believe if you're looking for something like that, though, Seeing AI does have a currency recognition channel, so that could be a good solution. Yes, and maybe one more before we
Okay,
move
one
on,
more
'cause I don't
question,
wanna.
and then we'll.
Yes,
take some more.
that'd
Go
be
ahead.
great. Thank you so much.
Yes, when you're doing these wonderful videos and things, and working with a client to help provide the video with you, it would be a really good idea if you told them to slow their device down so that it speaks English that most people can understand, because they're so used to reading it faster for their own needs that they forget that in cases like this, it's important to have it slowed down. So I think in future filming attempts, it would be a good idea to make certain that those apps were reading it at reasonably slow speeds, so that you don't freak out the sighted people, because they can't understand it, and some of us can't either. And I had one more quick thing about that. Yes, when dealing with the dates, I heard some dates read there, but I don't know if that was the use by date or the sell by date or the best used by date. Mm-hmm. There are different things, the reasons they put dates on. And I would like to have not just the date there, but the specific reason for that date, because it's important to not confuse the sell by date with the use by date, because they can be very different.
Yes, I totally agree. That is a great point. That's actually something that we heard a lot from people that we tested this app with. So all of the things that we're showing today are definitely works in progress. This app has not been released yet, so we're still in the process of refining it, making it more robust to those situations. So that's definitely something that we want to include in the future, hopefully. But yeah, no, thank you so much for the suggestion. Okay, I think just for time purposes, we kind of need to continue through the slides, but we will be up at the booth after this, of course, if there's any questions that we did not get to during the talk. Okay, I will keep going if that's all right with everyone. Okay.
So one thing to add is we'll also have some time after the talk for a question. And so for the question about currency and maybe many other things you want to recognize, so this project is meant as a way that you can easily plug in and play with many different models. So for example, if you want to detect certain things, so this program structure is currently like find X on Y, right? So you can have a bunch of different models that detect the object, and you can have different models that understand the semantic category of the information that you're trying to find, and you can play with it to figure out what's the most necessary. And we are also like designing the system informed by the use cases that Jalen presented earlier. Okay, so moving on, another project that we recently did to make the real physical world accessible is called WorldScribe, which we are trying to push the boundary of how much we can provide automated live visual descriptions, right? This is extremely hard, but with many of the advances in large language models, we want to see how far we can achieve this. And one of the big challenge is many of these models take very long to run, and it doesn't really do it in real time. So we had to engineer architecture that's able to take many different models into the information, combine them, schedule them to provide information. So another key point is how can we provide people the right amount of information? How do we allow people to specify what is the most critical information they care about? And we want to provide information that's not too much, not too little. And also when the user is, for example, walking around, they're switching their viewpoint very quickly, what kind of information we provide? Maybe like quick labels about what's going on. And then when you are kind of focusing on a certain viewpoint and the object, it will then start telling you more and more details about it. So I will show you first a couple clips about this project here.
WorldScribe provides basic descriptions with word-level labels when visual scene changes quickly.
TV. TV. Refrigerator and cabinet.
WorldScribe provides general descriptions with objects and spatial relationships when visual scene changes slowly.
A modern kitchen and dining area features a white countertop, sink, and refrigerator with a wooden floor, white walls.
WorldScribe provides consecutively succinct descriptions for complex visual scenes and prioritized based on the proximity to the user.
Coat hangs on wall. Countertop holds various items. Wall speakers are mounted. Dining chairs surround table. A modern kitchen and dining area features a white countertop, black stove and sink, with a large window offering a view of a brick building.
So in these clips, it's basically, if the user is moving quickly, is providing the more succinct information so that they are also less outdated. But as the user is kind of zooming in, or maybe the user can request more information on the fly through conversational interactions, the system will provide those interactions. And, we are basically trying to provide live descriptions that are very contextual, and contextual can mean a lot of things. And we are also thinking about, okay, what does the user's auditory context look like? Like if someone is talking to them, or if the environment is generally loud, then what do we need to do to manipulate these descriptions on the fly? Yeah, so those are a couple of projects that we recently worked on to make the real world more accessible. And lastly, it's an area that is potentially futuristic, but we can see it coming in the next years, which is like making immersive media and immersive experiences accessible. And one example is about 360 videos. Right, so traditional videos are made accessible through audio descriptions. But when you think about trying to describe 360 videos, there are not a lot of new challenges. Like, for example, what do you describe? What is the storyline? And how can you prompt the describer to create these experiences? And how do we provide similar level of immersion that sighted people may have and the interactivity to blind users? So in this project, we kind of investigate, how do methods and tools to make 360 videos accessible. So we developed a web authoring interface that uses kind of different computer vision AI models to analyze the video in different viewports and allow a describer to be able to, for example, drag a path following an object or do that automatically, and then the description can be spatialized. So we call this spatial AD. And we also make a simple mobile prototype that the user is able to move around, navigate through the video, and then hear specific information. So I'm going to play a couple of clips of what we imagine the experience will look like for audio descriptions for 360 and future immersive videos.
Standing right in the middle of Kenya's first community-run elephant sanctuary.
So
here is a savanna. The elephant house is on the left front.
Home to orphaned baby elephants.
And a jeep is entering the elephant sanctuary.
So that was a video taken by San Diego Zoo about the elephant sanctuary. So as you can hear, first is the video's narration, and then the audio description is provided spatially that follows that truck or whatever objects that's being described. Other than these kind of inline audio descriptions that fits into the gaps of the video, we also try to provide more interactivity by enabling scene descriptions and object descriptions. So scene descriptions sounds like this.
Now you're back to the elephant square. The keepers are feeding the baby elephants with formula milk.
And then object descriptions.
A baby elephant, waist high as an adult, is drinking milk from an elephant keeper from a white plastic jar that has just been filled with formula milk. The keeper is feeding the baby elephant. The elephant raises its trunk to the keeper's face in front of it. The keeper is feeding the baby elephant.
So these are potentially extended descriptions that the user, once they switch into a new scene, they're able to hear an overview, and then they can kind of navigate and point to or using whatever other interactions to kind of learn more about the objects. And you can imagine integrating many of the other stuff that we have done, such as, you can ask more questions about what this person is doing, what the elephants look like, and what is this elephant doing in relationship with another person or object, right? So this is a brief kind of, this is also a project that we're continuing working on to make immersive videos accessible. And yeah, so back to Jalen.
Okay, one more project in this immersive technology space is thinking about augmented reality or AR, where visuals are layered on top of videos from the real world. And these AR mobile applications are becoming pretty popular for different use cases. So on the slide here it shows the IKEA app where you can use AR to place furniture in your home and get a sense of, well, would it fit in my house? What does it look like? And on the right is an educational app where someone can see the Statue of Liberty in their home and learn about it. But this content, this AR content in these apps are pretty primarily visual. Oh, and if I use these apps with a screen reader, it doesn't actually tell me anything about the AR content currently. If I'm lucky, they might have made the buttons screen reader accessible, but even that sometimes is rare with these apps. So this was a project thinking about how can we make these augmented reality apps on mobile accessible if they're going to be used in cases like education or home services. This is super important. So we kind of followed 3 general goals in this project. We didn't want our prototypes to rely on any sort of precise camera aiming. So a lot of times with these AR apps, you have to aim your camera at a specific object or a specific point. It requires a lot of precision, so we wanted to avoid this. We wanted to retain some spatial and immersive aspects to the experience, and we wanted to provide access with familiar screen reader controls. So next I'm going to show a clip of a prototype AR furniture placement app like the IKEA app that we developed to have audible descriptions of what's going on. And in this clip, it's going to show someone selecting a piece of furniture from a list. They then place the furniture around by physically walking around their environment, and then they can hear details about the virtual objects that they place by scanning their camera around in the space. And this work was also done in collaboration with Apple.
Cancel. Button. Items. Mahogany chair with blue cushion. Button. Confirm placement. You are now holding the mahogany chair with blue cushion. Item doesn't fit here. Item fits here. Confirm placement. Found mahogany. Add furniture. Button. Left mahogany.
Okay. And then...
Okay, so the last one we are going to briefly touch on is this new area that we are designing for, which is like mixed reality sound awareness. So as we imagine, mixed reality soundscape can have a lot of information, right? So for example, if you are, let me give you an example. If you're walking down a busy street and, with ambient and crowd noises, while you're also listening to, navigation directions or maybe even participating in the Zoom call at the same time, there's all this information that's happening at the same time, but it's hard to discern and differentiate. Right? So we are thinking about, okay, how do we manipulate sound to craft a soundscape that can enhance the sound awareness for this increasingly going to be like mixed reality sound context for blind people. And we kind of draw inspiration from what is already out there for mixed reality and visual information, from reality and virtuality, and there's a continuum, and we draw the analogy to full transparency and noise cancellation, and we want to manipulate a lot more things in there that's in higher granularity. So we propose this concept called sound shift that manipulates sound to increase mixed reality awareness. And we kind of propose a set of manipulators that I'm going to play a short video here.
Transparency shift controls the ambient sounds or noises to shift the sense of presence between the real world and virtuality by manipulating acoustic transparency to occlusive opacity. Envelope shift modifies the dynamic aspects of sounds, such as volume, or pitch, affecting their perceived loudness and tonal characteristics over time. Then, position shift controls the locations of sound sources to enhance the sense of immersion. Style shift transforms the timbre and fidelity of sounds through various filters to modify their aesthetic and emotional impact. Sound append appends auditory cues for corresponding sound events. Finally, time shift prioritizes sounds by manipulating time so that this sound does not overlap with my voice.
Yeah, so with these kind of different manipulators that we imagine, you can create like very interesting combinations to manipulate your soundscape. And some example applications that we kind of conceptualized and we are thinking of developing in the future are, the first one is, think about, you're engaging in an online meeting, right? So you have multiple people who are talking, and you also want to use this voice, the screen reader, to navigate through the menus and read the chat. And those information can be overlapping. So how can we maybe prioritize things in certain ways, or change the volume, or move them to different parts of your soundscape? Like maybe the person is sitting in front of you, we can spatialize them, and we can change the voiceover, the screen reader audio to be behind you, so they can help better leverage your sound perception ability to understand this content at the same time. Another application is kind of motivated earlier, which is, think about that you're walking down the street, you're listening to audio direction, and there's a loud noise happen, right? So maybe our system is able to hear that loud noise and just wait a little bit and deliver that audio direction, so you can still perceive that. And there are interesting challenges to consider of how to still provide the most in-time and appropriate information. And then, as mixed reality content is becoming more popular, how do we communicate the real and the virtual using different kinds of style and methods here? So these are some potential directions that we are interested in bringing this specific project forward. And so I just want to do a quick recap. So today we talk about a range of topics and stages, like the range of topics of physical appliances, digital media, real world, immersive media. And many of the projects are at various stages, right? Some are very research prototypey. The system is, maybe there's a prototype that doesn't work very robust. Some are kind of at the potential deployment stage, but are still not market ready. So we are kind of looking for feedback and hope to get your involvement to help us shape the research and give us feedback. So do you want to take the last part, maybe?
Yeah, sure. So I know Anhong mentioned at the beginning, we involve people in our research essentially at every stage. So we've involved lots of people so far, but we're interested in involving more in the future. We conduct both in-person and remote paid research studies where people can try out new technologies. Sometimes we just interview people about their use of technology. Sometimes we tell them an idea and they tell us what they think about it. All that good stuff. These are all things that we do with our research participants. Sorry, I did not know what slide was on the screen. So if you're interested in getting involved with our research in this way, in being a participant, or if you know someone who might want to participate and, like Anhong said, shape the future directions of this research, we have a Google form on our website, and I'll say that again. It's Human AI Lab, all lowercase, that's HUMANAILAB.com/visions, that's VISIONS.HTML. So that's humanailab.com/visions.html. And if you don't have a device for this form, or if you don't want to remember all that, you can come to our booth upstairs. We have computers, we have people that can take your information. Like I said, the people are really what make this research possible. We would not be able to shape these future technologies without people's input, and nor would we want to, right? We cannot presume to know essentially what's best in these technologies. So it would not be possible without the amazing folks that we've worked with in the past, and hopefully some of y'all in the future. So I think that's everything we have, but thank you again.
Yeah, and we will be happy to take more questions until maybe we are kicked out for the next group.
Yep, let me just. Okay. I was wondering about the level of privacy protection on some of these things. Like if I'm carrying around my phone, like what information's being sent off to somebody else that I have no knowledge of or whatever. Like, what are the privacy protections, basically?
Yeah, so for our research prototypes, for example, the ones that we run in the lab, we typically provide a device So you come in, and everything is processed within our secure server and stored. And all of the studies, we go through a rigorous IRB process. So we go through our institutional review board. We document the study, and it's approved. And there is a specific consent form, and we pay people, we inform people of what data do we collect. And so that is the process we follow. For the apps that we deployed, we also document very specifically what data we're collecting, and we don't collect more than what we need. So for example, for the VizLens and the ImageExplorer apps, we definitely need the image to be able to do the analysis. And also for those apps, we also provide an in-app opt-in study. So you can choose at the beginning of your sign-up whether you want to help us by contributing your data. But when we analyze the data, we're also not going to just put it out on the web, on public, but we are able to use that to write a paper in an aggregated fashion to inform the community and industry practitioners of what's the best thing to do in the future. Yeah, so we take that very seriously. And thank you for that question.
Okay, another question here.
Hi, thanks for your presentation. I'm just wondering what the long-term plan looks like for these prototypes. It sounds like at some point they go to market. I'm just wondering what the long-term support looks like for them, because sometimes it seems like these really specialized apps for people with disabilities tend to come and go.
Mm-hmm. Yeah, that's a good question. And also through our experience working on those deployments, we also realize this is a challenge for example, a research lab. Right, so we need to solicit funding and partnership. And I think in the long term, we want to inform how assistive technologies are designed and developed, as a whole. Not necessarily these are from us, but for example, for VizLens, right? We have built this system and we have shown these, and maybe someone pick it up. And for example, Apple now has a quite similar experience in their magnifier app, and we are very happy to see that. And if they are able to make it integrated into their system, they are able to do it better than what we can do because they have the low-level integration and all that. And so at that point, we're happy to see that's taking off, and maybe we shift to making it on Android. So before Android provide that support, and then eventually we fade off our support. And and in other cases, we show what is possible and what is feasible, and then we can inspire I don't know, big companies or small startups, and we can partner with IRA and Microsoft, Google, Apple, and these other companies to basically try to make the world a more accessible place. So I think that's the ultimate goal we want to do. Yeah.
Any other questions? Could you just repeat the Apple app?
Yeah, so the two apps, one is called VizLens, VizLens.org. The other one is called ImageExplorer.org. And both of them can be found on this one website. We try to make this easier for you all to access.
Thank you.
Yeah, maybe one last question. Yeah, go ahead.
Sure.
The mic is coming now.
Okay, I'm just curious, if you go to humanai.com, can I peruse all the different projects you guys have going on?
Yes.
And see what you guys have?
Yeah, so if you go to humanailab.com,
humanailab.com,
that will be redirected to my personal website, which, yes, it lists all the projects, but it's more for academic audience. So there is each project, there is the publication link, the video, the talk, the potential source code, the external website, and all that.
Oh, wow. Yeah. So how close are you to letting me have this ChatGPT thing where I can have the world described around me on my iPhone?
You mean the world described one?
Yeah, today?
Well,
can I have it even if it doesn't work perfectly? I can still use it and sign a waiver that says it's all my responsibility, or what can I do?
Yeah, I think that one is really promising, and we're very excited about it. But when we did the study, we had to use our own lab server, which is pretty heavy, and we run a bunch of the models. But you see GPT-4o is out, and there will be more models that's out. So I think within maybe a couple of years, something like this will be out there, and we're also working on it.
Just the feasibility of having to run all the back end stuff like that.
Yes.
Because I can't. I'm about to lift off the ground when I think.
Okay, we need to end this and give a nice round of applause for our presenters today. Thank you. And then the next group is coming in.
Yeah, the next one coming up at 2 p.m. is a technology talk with JJ Meadow from the AT guys. You're welcome to stay. We have sighted assistants at the back. If you need assistance leaving, just raise your hand and someone will come to you. Thank you.